So today what we will do today what we are going to do here is we will be working on the concept of basic configurations of the entire course. Whatever the course requirements are there, all those basic configurations we will be installing on a computer, and then we will be going ahead into the concept of Terraform. Okay. So how we can create the Terraform and how we can install the Terraform, what is the language that we can use for the Terraform. All these things we will see in this session. One second. Okay. Now let's get started with the concept of what are the pre-requirements of the Terraform. Okay. So now whenever you want to understand, first of all, let us understand about what is this Terraform and everything. Everyone are saying in right now in every company they are requesting, maximum number of the companies are requesting to have the knowledge on infrastructure as a code, nothing but Terraform. So why they are going with this? Manually we can create the resources. No, manually we can create the resources. Then why we need to have Terraform? See, if I can create the resources manually, yeah. So for example, let us take an AWS environment. Okay, I'll go with an AWS cloud. In the AWS cloud, first of all, what I have to do? First, we need to configure the network. See, in a very big company, okay, there is a company where there are some what I can say, where there are some 5 6 teams are there. Okay, just I'm taking an example. It's a company where there are 5 6 teams are there. Those are development team, accountant team, and then we are having the operations team, delivery, okay, application delivery team, sales team, sales and marketing team, the HR team, like that. So in the same manner, whenever we are creating an environment in the AWS, first of all, what we have to do is we need to create a VPC. So what is VPC? VPC is a very big network. Okay, one small or else one big network where you can create all your resources, just like your office space. So what is that office space? It's a very big area where you will be where all the employees will come and do their work. In the same manner, here also VPC is a network where all servers can be deployed, any resources can be created. Okay, it's just like a network boundary that will specify that this particular resources belongs to this particular company. So that is called as a VPC. Here we are going to create a VPC. And how we are dividing the teams inside the office, there will be some 1,000 people can come and do their work, but we are dividing each and every employee depending on their capabilities as a team. So like how we are going to divide, like development team and then HR team, finance team, operations team. In the same manner, here also, whatever the VPC is there, this entire very big network, it can be divided into small networks. Okay, why we are dividing? Those are called as subnets. Whatever the VPC that you are having, that we can divide them into subnet 1, subnet 2, subnet 3, and subnet 4. Okay, so this is how, like, I'm just giving you an analogy with the office environment. You have a very big office. Inside the office, you are having how you are having the teams. In the same manner, we will have a network. Okay, in that network, we can create our resources. Okay, so those resources can be divided into small networks. Okay, so we can create the networks. And these small networks are called as, whatever the big network, the VPC is divided into small networks, those are called as subnets. So inside the subnets, what we can do, we can create the resources. Here I can create a server. Okay, I can create an EC2 instance or server. Okay, so when we create these EC2 instances, if the EC2 instances are the subnets that are directly accessible by the internet, Okay, so we have two subnets, subnet 1 and subnet 2. These are connected to the internet gateway so that they will be able to access the internet. Okay, all these two subnets, subnet 1 and subnet 2, are connected to the internet gateway. Who will tell that I have a route towards the internet gateway? There will be a routing table. So what this routing table will tell here is, okay, the routing table will tell that, so these subnets, whatever the subnets that are connected to this routing table, they can be able to access the internet directly. So then those are called as public subnets. The subnets which can access the internet directly are called as public subnets. So how they will be able to access? Through the routing. If there is a route towards the internet gateway, okay, so this route table will tell that route table will be there. So this route table will tell that if anybody, I mean, if any resource wants to communicate with the external resources, external websites, then they must connect to the internet. And those resources are called as public resources, just like your manager, CEO, CFO. So who will be directly interacting with the client outside of your office? Who will be directly interacting with the client? So in the same manner, here also there are a few servers that will be directly interacting with the internet. Okay, so those are called as public resources. Okay, so in your office premises, who is the public resources? The manager and the, what I can say, manager, CEO, CFO. These are all called as public resources, where they will be able to access by anyone. I mean, those resources, I mean, the manager can talk to the client, CEO can talk to the client, CFO will talk to the client, accountant, head of accountants can be talk to the client to settle out all the amount and everything. So like that, some people will have the direct access towards the external environment. In the same manner, here also, some devices will have the connection to the external resources, then they are called as public resources. I mean, external resources in the sense internet. And a few servers will have, or also a few subnets will have, that don't have the access towards the internet. They are called as private resources or private subnets. Just like a normal employee, a developer is there. A developer cannot directly talk with the client. If there is any requirement, the client has to approach the manager. From the manager, the request should be coming to the developer. So here, if the developer wants to communicate with the, like, if any private resource is there, this is a private subnet. The private subnets, whatever the servers that we are creating inside the private subnets, they will not directly communicate with the internet. Okay. So if they want anything, first of all, what they will do, they will connect to the NAT gateway. So this NAT gateway will have the access towards the internet. Okay, they will be connected to the public subnet, and from the public subnets we can reach out to the internet gateway. From there it can reach to the internet. So if any private subnets are there, like just like your normal employees, if they want to communicate with the client, they won't directly communicate. The request to go to the manager, and the manager will talk to the client. In the same manner, here also the server will talk to the NAT gateway, and this NAT gateway will talk to the internet. So whenever the client respond back, the client will be responding back to the manager only, so that the internal employee will be safe. So here also the same process. So if the server is there, if this server wants to communicate with the internet, so the communication will happen through the NAT gateway. Okay, so the request will go to the NAT gateway. From the request, from the NAT gateway, it will reach out to the internet, get the resources, whatever the resources that are requested by the private server, and giving it back to the private server. So this is what going to happen. But if anybody wants to talk directly to the private server, it is not possible. Why? Because here you are having the NAT gateway, just like your manager. So they have to contact through the manager only. So in the same manner here also, why? Because you are not going to be exposed outside. Whatever the doubts, whatever the clarifications that you require as a developer, everything will be given to the manager. Manager will talk to them. So in the same manner here also, whatever the request that you want, the request will be given to the NAT gateway. The NAT gateway will talk to the internet, and the resources can be downloaded into your servers. So this is about the basic infrastructure which we are going to create. Now the point is, these are called as whatever the servers inside the public subnet, they are called as jump servers. Jump servers, or else we can call them as an what I can say Bastion host. Okay. So sometimes what will happen, these kinds of environments I have to create multiple in the office premises. For example, I might have created, okay, there is another requirement for my company where I have to create the same kind of resources. Sorry, 1 second. Where I have to create the resources so that what will happen, there will be a security configurations will be there, and then you will have the rest of the configurations we have to do. For example, this is the VPC. Another VPC I have to create. Okay, for the same application. This VPC is the security VPC. Okay, so if any request that comes to the comes from the client, if any request that comes from an user, okay, so in this VPC you might have your application running. This is the VPC where you will have your application running. So I will call it as application VPC, application network. This is my security network. security VPC. So if anybody wants to, if any outsider wants to enter, first of all, they have to be, the security check has to be done, right? So in the same manner, if any request that comes to your application, the request will be first forwarded to the security VPC. From the security VPC, we have to connect to this VPC. Okay, so we will be using a transit gateway. Okay, with the help of transit gateway, what we can do, or VPC peering, we can establish the communication between these two VPCs. Now see here, whenever we require the infrastructure, slowly what is happening? Slowly the infrastructure is increasing. Okay, so when the infrastructure is slowly increasing, then the configuration will be the how we are going to do the configurations are also going to be increasing. So manually, if we have to do this, it is going to take a lot of time and we have to put a lot of efforts. If one single mistake, the entire configurations might be, what I can say, they will be wrongly configured. Again, we have to do it from the beginning. So to overcome this problem, what we are doing here is we are going with the writing the entire or else creating the entire infrastructure with a code. So that whatever the configurations that we have to do, we will write the entire infrastructure as a code. Okay, we will write the complete infrastructure requirement as a code. Come on. As a code. Okay. The requirements will be written in the form of code. Which code? So the language will be called as HCL language. HCL means HashiCorp language. We are going to create in the Terraform. Okay, so now let's see how we are going to create. Up to now, is it clear? Up to now, is it clear? Whatever we have discussed. Any questions?
So the transit gateway, which you were just saying, right?
Tell me.
Yeah. So can you just give examples of means what are these services exactly which are named in AWS?
Those are the resources which we are creating. Do you have the knowledge on AWS? I'm sorry.
Uh, yeah. Means likewise, a virtual machine in AWS is called as EC2 instance, right? So
Yeah.
likewise, transit gateway, what do we call? So that was my question.
Transit gateway is a resource which
Okay.
will be
So,
connecting two networks.
okay.
Okay, it's a resource. It's not a server here. Okay, it's just a resource which will be connecting. It's a network resource like your router. How two networks can be connected? Transit gateway. I won't say router, but it is a resource which will be connecting two different VPCs, two different networks. Okay.
Yes. Yeah. So my question was like,
Mm-hmm.
means the Kubernetes service in Azure is called as AKS, and in Google Cloud it is called as GKE, and in AWS it is called as EKS, right?
Mm,
So
mm.
likewise, transit gateway, what do we call in AWS was my, that's it.
The resource name is Transit Gateway in AWS.
Oh, okay.
There is no another name for it.
Okay, sir. Okay.
Why I am creating Transit Gateway here means the resource name itself is a Transit Gateway. Here I can create a router, no? I have to connect these two.
Okay.
If you want a generalized name, I can put like router. But why I'm
Okay.
putting it as
Yeah,
a
that.
Transit Gateway? Because it's a resource name. Here also you can see I can say it as a network. Why I am calling it as a VPC? Because this is the resource name which we are creating. No, if in
Yes, sir.
Azure it is called as VNet. Okay,
VNet. Yeah,
in
yeah.
the GCP it is called as same VPC only, Google Cloud VPC. So in the same
Okay.
manner in AWS it is called as a VPC. Whatever the names that I have given over here, those are all the names of the AWS environment only. Okay,
Okay, sir. Yeah, got it.
right. So
Yeah.
now what we have to do here, we need to install the Terraform and then we will check a few configurations. So this is your computer. Okay, inside this computer, in general, when you log in into the computer, by default, what you can see, we won't have any resources. We'll not have any sort of resources. And then, first of all, my requirement is that, so this is the clean computer, the basic computer infrastructure which you got. Now, what is your requirement? First things first, you need to create the, or else you need to install the Terraform. How we are going to install the Terraform? So first we want to have an IDE. IDE in the sense, you know how to, IDE is nothing but the application which is helpful for writing the code. Eclipse, Visual Studio Code kind of applications. So we are going to download the Visual Studio Code. Okay. One second. VS Code download. So this is for writing the complete configurations and infrastructure management and writing the code. So I'm going to download the Visual Studio Code. Let me download it. Okay. So the Visual Studio Code has been downloaded. Once it is downloaded, what we can do, we can just simply install the application. Okay. Visual Studio Code setup. Yes. Next. Next and install. That's it. So the Visual Studio Code will be installed. Once the Visual Studio Code is installed, now it's time to install the Terraform. Okay. So let me do one thing. Right now I am having a single hard disk of size 60 GB. Okay, it is having of 60 GB. Let me divide that into two partitions for my code configuration. I don't want the seed in C drive. I don't want to put my entire code configuration. Let me divide that. Shrink the volume. Hold on. It is taking longer. 10240. I'm shrinking it to 10 GB. 10 GB is sufficient for our entire course. Use simple volume. Next, and finish. So here we have the 10 GB drive created. Okay, and finish. So here we have our 10 GB drive is there. So inside that we are going to work. So now we have the Visual Studio Code installed. Okay. So now it's time to create the Terraform or install the Terraform. Now what I can do, terraform.io. Terraform.io. So this is the website from where you can download the Terraform binary for my Windows environment. Simply click on download. Okay, it is going to download the Terraform for our Windows environment. Here you can see the Terraform has been downloaded 1.14.5. So let me extract it. Extract all. So I will extract here itself. Okay. So here you can see the Terraform application is there. Now what I will do here is, in this PC, in E drive, I can create a folder called as tools. So whatever the required tools are there, all the tools I will put this in the folder. Now whatever the Terraform that we downloaded, let me copy this and give it into the tools directory. Okay, done. So we have the Terraform application saved in the tools directory. So this is the binary. Okay. Now what you have to do is, so whenever we go to the PowerShell, in the PowerShell, what I am going to do here is or else if I give Terraform version. So when I give Terraform version, the command which I am giving, so Terraform, what PowerShell will do? PowerShell will search for this application in the path. Where is the path available? So here you can see the path is available. The environmental variables and the paths are available in the system properties, sysdm.cpl. If you go here, this is the system properties. In the system properties, if you go to the advanced environmental variables, here you can see the path. These are the user variables path or system variables path. Any path you can take. So whenever we fire a command, when we fire this command, so whatever the Terraform command is there, no, so the computer or else the operating system will first go and search in the environmental variables path whether that particular application related path is there or not. So where is this application available? So where is this binary? So commands are nothing but the binaries. Binaries are nothing but the compiled code. Where is this binary available, Terraform binary in the path? So it will search here. So if it find out the path, then it will tell that uh, then it will give the appropriate output. Otherwise, it is going to show you Terraform is unknown. See there, Terraform is not recognized as a name of commandlet. Function, script file, or operable program. Check the spelling of the name or if the path was included. So see there, if a path was included, verify that path is correct and try again. So the path is not included. We need to include the path in the environmental variables. So go to sysdm.cpl again, advanced environmental variables, path, edit. Here you have to provide the location of the application. So where is this Terraform binary available? That address you have to provide, eTools. When you provide it over here, then what will happen? Or else in the user variables also you can put, no problem. Either you can put them in the system variable. When you put them in the system variables, that will be applicable for all the users. When you put the path for in the user variables, that will be available only for that particular user. Okay, so that's the main difference. Any which ways, we have updated the Terraform application related information in the path. So now what will happen here? Now if you execute the command Terraform version, previously we got the error, so unknown command, but now here you can see the Terraform version it is showing. Why? Because the application, whenever you fire the command, the operating system will check in the path. So if that location is available, then it will try to fetch out that application and it will execute the application. Okay, so here we are able to see Terraform version. Okay, so now Terraform got installed. So first things first, what Terraform will do? Terraform will be able to create the infrastructure. Terraform will be creating the infra. Okay, how it will be creating the infrastructure? Infra in the cloud or on-premises environment. On-prem environment also, Terraform will be creating the infrastructure. But here we are going to remove this on-premises. We will be talking about the cloud. Especially we will be creating the infrastructure in the AWS environment. In AWS, we are going to create the infrastructure with the help of Terraform. Okay, so how it is going to create the infrastructure? So first thing, Terraform will use the code which is written in HCL language, which is written in HCL language. Okay, through that code, through the code, it will create the resources in the cloud environment. Okay, in whichever the cloud that you are talking about, either it might be AWS, it might be Azure, depending on the code what we have written in HCL language. So with that, it can create the resources in the cloud environment. HCL is nothing but HashiCorp language. HashiCorp language. Okay, HashiCorp. What is HashiCorp? HashiCorp is the company which created the Terraform. So the company which created Terraform is HashiCorp. Not only Terraform, it created so many tools. We'll discuss further. Okay. So now other thing is Terraform is idempotent. What is idempotency? Idempotent in the sense, for example, you created a resources. So we created a resource. A resource is created. For example, with the code. A resource is created with the code. Now, how Terraform will know that? So when the code is there, for example, let me show you. I'll go back here. This is my Terraform underscore basics. Okay. So first of all, let us see the workflow, and then we will come back to this idempotent kind of thing. So what is the Terraform workflow? Terraform workflow will be first writing the code, and the second one will be validating the code, and the third stage, first stage is writing the code, second stage is validating the code, or else validating code and initiating Terraform. And every time initiation is not required. First, whenever we are executing for the first time, then only we need to initiate the Terraform, and then we can validate the code. And finally, the third step is planning, or else dry run the code, so that we can understand which resources are going to create. Okay, so with the help of dry running, it's just like a planning. Okay, we'll call it as Terraform plan. What is meant by planning? So Terraform will tell us these resources are going to be created. So kind of. So this is what we call it as dry running. So with the dry run, what is the advantage? Before creating the resources, we can come to know that which resources are creating, and what are the properties, resource properties, like what is the network range, what is the name of the resource, where it is getting created. These are all the information will be there in the plan. So it is better to go with the plan before creating the resources. Simple. Before constructing a home, how we are going to have a home plan. So without that plan, we cannot construct, no. So in the same manner, here also we are going to create a plan so that we can understand which resources are getting created, kind of. Okay. So if plan is not there. Okay, if the plan is not there, then directly if you are creating the resources means, then it will be a lot of hectic problem will be there. Just like in movies, so how you need to have the bounded script. Okay, story bounded script is needed. So if the script is not there, then that movie is going to be, we cannot say that might become a hit or else that might become a flop. Sometimes it might become a disaster also. So in the same manner, here also the same thing. First of all, we have to write the code, and then the code should be executed as a plan. Dry run should be done, and finally it has to go for the fourth stage will be uh, creating resource, creating resource in the environment, in the cloud environment. So this is called as apply. These are the workflow stages. The first stage is writing the code, initiating the Terraform and validating the code, dry run, checking what are the resources that are going to be created, and finally creating the resources. So this is what our requirement is all about. So let's see what is going to happen here. So now here I created a Terraform basics. Now you understand what is the flow of Terraform. Any questions here? Any questions?
No.
Okay. Now I want to create the resources. Open with code. So Visual Studio Code will be open. Now in the Terraform basics folder, the Visual Studio Code will be open. So here we need to install two extensions. I will install two extensions so that writing the code will be very, very easy for me. So what are the extensions that I want to install here is Terraform. In the extensions, type Terraform and install these two extensions. HashiCorp extension also. When you install these two extensions, your writing the code will be easy. It's not a very complex code. It's very simple. So the syntax for creating the resources with the help of Terraform is syntax for creating the resources is in Terraform is Terraform, sorry, not the Terraform, resource, and then you have to provide resource type AWS. I'm just giving an example. First of all, let me give the syntax. Resource type, resource underscore type. For example, here we can provide like AWS underscore VPC. AWS VPC means it's a resource that we are creating, VPC network resource. Okay. And then you have to give the reference name. Reference name. So this is not the name of the resource. This is just a reference name. Okay. So why we need to have the reference name, and then we have to provide the properties of that particular resource. So what is this reference name? This name will be understandable by your Terraform. Why Terraform has to understand this name? Okay, so that I will tell you. But before that, first of all, let us go and write the code. And whenever the time comes, I will tell you about the resource name. Reference name. First things first, what is our requirements? Our requirement is that we need to tell the Terraform on which cloud environment we are creating the resources. So here I have written provider.tf file. So you can write main.tf, main.tf, or else you can write your company name.tf. No problem. Anything you can write is polaris.tf. Like that, I can write any file name, but for my understanding, for my ease of understanding, what I will do, I will create like provider.tf. Provider.tf in the sense who is the provider that will providing the resources, that will providing the infrastructure for our project, whatever the project that we are doing. For that project, which cloud is providing the resources. So here I will give like provider AWS. AWS is the provider for me. So AWS, in the AWS infrastructure, we are creating the resources. Okay. So now I am telling the Terraform that we need to create the resources in the AWS environment. When I tell the Terraform, I have to create the resources in AWS environment, then how Terraform will know? Terraform is an application. So Terraform is an application which is installed in a computer. So right now, I have my computer like this. Just hold on. So in this computer, what we are having the Terraform installed. This is my computer. Inside this computer, I install the Terraform. Okay, this is good. But how Terraform will be able to, what are the resources that are available in AWS environment? Here we have the AWS cloud. Now I am telling the Terraform that you have to create the resources in the AWS environment. The first thing is it will try to create, or else it knows that okay, I have to create the resources in the AWS environment. But what are the resources that are available in AWS environment? How Terraform will know that? Okay. So in simple, in software language, if I have to tell you, for example, there is an application. Okay. That application, I am providing the payment as UPI transactions. Okay. I am providing multiple payment methods. So how my my application will come to know that this payment method is UPI payment method and it has to connect to this particular account? How it is going to know? In the back end, in the UPI, you will be having several applications, no, like Phone Pay, Google Pay, Paytm kind of things. So how that the payment API or else payment application will know that the user is trying to connect to Phone Pay, the user is trying to connect to Google Pay, or else the user is trying to connect to some Paytm or else some another UPI application. How my application will know that? Yeah. Any developers or also anyone who can tell this answer? Do you understand the question? Let me rephrase it like this. Will you do the e-commerce? I mean, will you do the online shopping? Will you do the online shopping?
Yes, sir.
It's not a technical question, right? It's a
Yes.
general question I'm asking. So when you do the online shopping, will you check out or else will you do the payment or just window shopping? Are you going to do the window shopping? If you want to purchase a product, you have to do the payment.
Yes.
When you click on payment, what you are going to do? There will be several options will be there in front of you, like UPI transaction, credit card, debit card, net banking, cash on delivery, EMI option kind of things will be there. For example, if I select the UPI, it is going to show you a few applications like Phone Pay, Google Pay, uh, Beam UPI. Okay, so like kind of different applications it is going to show you. So when you click on Phone Pay, how it is directly connecting to the Phone Pay application? How application knows that this has to route to this particular Phone Pay? How that e-commerce application, the user has selected Google Pay, I have to select it. I have to transfer the, or else I need to connect to Google Pay to complete the transaction. How application will know about that?
IP address. Yeah. That.
Not the IP address. Think. IP address is not the one. We will have the plugins installed for those applications. We will have the APIs for those applications. In the same manner, here also what we are trying to do, we are trying to create, for example, I want to create the VPC inside the AWS environment. How my Terraform knows that I have to create the VPC? This is the VPC. So Terraform, whenever I initiate the Terraform, okay, so here you can see I written the code now. So what is the code that I have written? Provider is AWS. When I say provider is AWS, when I initiate the Terraform, Terraform will download the plugins related to that AWS cloud. Whatever the resources that are available inside the AWS cloud, all the resource related information will be downloaded as an plugin. So into a folder, in that folder you will have the plugins. Whenever it tries to create the resources, it will check is that resources are available or not in the plugins. If that resources are available, then it will create. Okay, so here what I will do, I will go back to my command line cd cd terraform basics. So here what we are doing, we are going to initiate the Terraform. Look at that, Terraform init. When I try to initiate the Terraform, here you can see initializing the backend, initializing the provider plugins. Who is the provider? AWS is the provider. So installing AWS HashiCorp AWS version 66.33, which means that this is the latest version that is available. Okay, so with the help of this latest version, what is going to happen? So whatever the resources are available in the AWS environment, all the AWS environment related plugins, resource plugins will be available in this HashiCorp AWS, what I can say, plugin, provider plugin. Okay, so here you can clearly see this, finding the latest version of HashiCorp AWS, installing HashiCorp AWS, and install HashiCorp AWS version 6.33 signed by HashiCorp. So Terraform log file created. To record the provider selections it made above, include this file in your version control repository so that the Terraform can guarantee to make some selections by default when you run the Terraform direct. So when we initialize the Terraform, it will download the latest plugins related to your cloud environment. If you are using Azure, so if I go for Azure RM, so it will download the Azure related information, Azure related plugins, so that whenever we want to create a resource, it can understand, okay, the user want me to create the resources of AWS VPC or else AWS EC2 instances or Azure virtual networks because of the plugins. Here also the same thing will happen. Okay, right. So this is what the provider that we are providing. In the another manner, what you can do here is, here you can provide your client version requirement also. What is this client version requirement? For example, I am installing the latest version. In the latest version, all the resources will be coming. Whatever the resources that are available in the AWS environment, every resource will be coming, like VPC, EC2 instances, S3 buckets, systems manager, and then we will have the cloud watch. We will have somewhere like what I can say, artificial intelligence, machine learning resources. Everything will be there in this version of latest version of AWS plugin. But for example, I don't want all these things. I want a bare minimum requirement. So then what I can do, I can declare the version of that AWS provider. How I can declare it? Terraform required providers AWS is equal to, what you can do here is, here you can set up the what I can say, version. So how I can do that? Terraform AWS provider. Here you can see the AWS provider over here. Look at there. You can give this. So the source is HashiCorp AWS and version. Here you can give version. So when you provide these kinds of statement, then Terraform will download the plugins related to this version. For example, I want you to download 5.0. Okay, greater than or equal to 5.0, then it will be downloading the most stable version of the 5.0 version. Now we are downloading the 6.0 version. So whatever the resources that are available in 5.0, that resources will be downloaded. That resource related information will be downloaded. If you go for the 6.0, whatever the resources that are available in the 6.0 version, that resources will be downloaded. If you don't give this block, okay, then latest version of the code will be downloaded. I mean, latest version of the AWS infrastructure plugins will be downloaded. In that, all the resources which are updated are available. So kind of like whatever, if you want, if you put this resource block, the meaning is that you want the resources up to this level, up to the version 5 level. So whatever the latest updated resources are there, those are all not required. Okay, so whatever the resources that are required, you can use the Terraform version. It is not recommended that you have to use the updated version only. Depending on your project, depending on the requirement, you can go with the resource version or Terraform provider version. So here I am going with the latest version only. But if you want to go with the specific version, you can select the specific version of the AWS also. Okay, so how I can tell you this? For example, you are creating an application. Okay, so the application version 1.0.1 is the first version, 1.0.2 is the second version. So why you are upgrading the versions? New elements are adding, so you are upgrading the version. In the in the latest version, you have in the application, you are having the biometric scanner, iris scanner, voice recognition, all these things are added. So that is over technical. Okay, so that application has become over technical. So I don't want that kind of application for my customers. For example, as a banking application, why I want the speech recognition, why I want the iris scanner. So simply if I have a biometric scanner and the password, that's more than enough for me. So whatever the application right now you have created, it is having over technicalities, and as well as it is going over the top. So now what I can do, I want to use the previous version. So I can just shift back to the previous version where I am having the limited resources. Here also the same thing will happen. So now if you are going with the updated latest version, it will have all the resources, updated resources, which might not be required by your project. So now if your project requires only up to a level of resources, then you can select the version number over here, provider version number. Okay, so that's about your provider configuration. You understand this? Do you understand this? Any questions?
No, understand, sir.
Okay. Everyone.
Yes,
Understand.
Okay.
Sir, one question here. So, in 5.0, so you have mentioned that version, right? So, what are the things are there in 5.0 and 6.0? How to know, sir?
You can check out that in the registry.
Okay.
So if you go to one second. Google AWS Terraform. If you go this registry, so what is the latest version that is available? See that version 6.3.0. So if you can see here, you are having all these applications are available. But if you go to somewhere like version 6.30.0, a few resources will not be available. Okay. So with this you can check out. Okay. So this is the Terraform registry where you will be having the AWS related environment are available. Okay.
And one more thing, sir. So you mentioned, so in ID you have written this HCL code, right? How like this the ID is able to download these all these services, or do we need any AWS account is required for this?
For creating the resource obviously we require the AWS account.
Okay.
We have to do the practice. We need to create the resources. We need to have the AWS account. Okay. So here now, okay, that's fine. Now we created the provider. Okay. Now I want to create the VPC. VPC.tf. What is this VPC? VPC is a basic infrastructure for your entire application. Okay, so where we want to create this application related resources, either it might be databases, it might be EC2 instances, where we want to create, just like a VPC means virtual private cloud. So you need to understand two things. We will be having what is VPC? Virtual private cloud. What is this virtual private cloud? So in cloud, there are two things. One is the public cloud and the other one is the private cloud. Before you understand the VPC, let us understand two things, public cloud and private cloud. What is this public cloud? Public cloud is a type of infrastructure or else the cloud which can be accessed by anyone. If you are having an AWS account, you can create the infrastructure. Okay, if you want to create your own application, simply if you have an AWS environment, it can become your proprietary infrastructure. So in the same manner, what is meant by a private cloud? Private cloud means the infrastructure which can be created by within the single organization. For example, I have Wipro, or else I have Infosys, or else I have TCS. So these companies will not be going on to the cloud environment. Why? Because they have their own data centers. So what happens in the private cloud means, for example, you have a company. In that company, we are having the resources, or else we want to create the resources. So what developers or else what the people can do here is, So this is the developers infrastructure where they are sitting and working on the application. For the same company, there will be another infrastructure. This is called as data centers. Okay. So inside this data centers, what you will have? Inside the data center, you will be having so many racks are available. What are these racks? These are the computer racks, server racks. So in this racks, what you will be having means you will be having the physical resources. Physical servers will be there. Inside the data centers, you will have the physical servers. Now, whenever you are having the physical servers inside the data center, now what will happen? If you want to create a server, okay, so in this racks, there will be so many physical servers will be there. Physical network equipment will be there. So now you want to create a server inside this environment, inside the virtual, you want to create a virtual machine. So how you can create this virtual machine? You will have a proprietary tool called as, there is a tool called as OpenStack. Okay, I hope you know about this. If anybody knows, that is fine. OpenStack. So in that company, they will install a tool called as OpenStack. Now, what these employees can do, the developers or else the infrastructure providers, so whoever are the delivery team is there, they can create the resources with the help of in their computer, they can open the OpenStack application. This OpenStack application will be connected to this data center network. And here I can create the virtual machines. Whatever the required virtual machines are there, I can create those virtual machines with the help of OpenStack. So here you can see this infrastructure, whatever the data center we have and the infrastructure we are having, we are not providing that infrastructure for the external users, for any another users. Only that company is accessing. So this entire infrastructure is a proprietary infrastructure for this company, whatever so-called TCS or Infosys company or any another company. So they have their own infrastructure. So this is called as a private cloud. What is meant by public cloud? So if we provide that infrastructure to the all the audience, all the people who are having the AWS account, so if everyone can create the resources inside my data center, so then that is called as a public cloud. Okay. I can create the virtual machines, I can create the databases, I can store my data in the S3 bucket. Here I can store the data inside my S3 bucket. This is the S3 bucket where you can store the data, and these are the EC2 instances. Okay. So now everyone will be able to access my infrastructure. Then that is called as a public cloud. If the cloud is belonging to a particular company, then that is called as a private cloud for a company or for an organization or for individual. So now in AWS, what we are doing, we are creating the VPC. What is the full form of VPC? VPC means virtual private cloud. Virtual private cloud. So just for an instance, forget about virtual. So here we are having the private cloud. So what is meant by private cloud? The infrastructure which can be belonging to a single organization is called as a private cloud. So here we are going with the virtual. What is meant by virtual? Virtual means it's an imaginary. So the cloud, the private cloud, or the organization which we are creating in the public cloud is called as a virtual private cloud. So we are creating the organization infrastructure inside the public cloud environment. Okay, so that is called as a VPC here. So now from where we came all the way here, when we want to create the VPC, okay, when we want to create the VPC, what are the required configuration? If you see here, if you want to create this infrastructure should be created inside a network. In the same manner, the VPC should be created inside the network. Okay, we have to provide that. VPC is nothing but a network. What is that network? The range of computers or servers that can be created inside a network is called as VPC. So the meaning is, for example, I want to create some 1,000 servers. It's not required, but I'm telling, if I want to create some 1,000 servers, all the 1,000 servers can be created inside this VPC. For example, I have a client called as Vola. This Vola client want to create their resources. I mean, they want to install the application in the AWS environment. For that, they want to create a network. They want to create the servers. Okay, let me do one thing. So this Ola company has approached me and asked me that, so we need to install our application in the servers, and the requirement is that that application should be highly available and it should sustain with the load balancing. Okay, it should sustain with the load, and as well as it should do the auto scaling. Auto scaling means automatically if the load increases, the resources capacity should increase. These are all the requirements that is set by the Ola company. So now, according to those requirements, what I can do here is, first of all, I can create a VPC. I'm going to create a VPC here. VPC means a network where you can have all your servers. So now inside the VPC, I will create two subnets. I'm dividing this VPC into two subnets. Why we are dividing? So we are going to create, okay, we are going to create the servers in these two subnets. Okay, two or more subnet. For example, not why we need to stick with two. For example, I want to go with the 4 subnets here. So this is subnet 1, subnet 2, subnet 3. For example, I am creating 3 subnets over here. So now in these subnets, what I can do here is, these subnets can be created across the region. So what is this region? You got a new term, region and the availability zones. Okay. First of all, let us understand, and I will come back to the subnets here. The first one is region. What is region? So this is the global infrastructure of the AWS environment. Region in AWS is called as a location, geographical location, where you are having your data center. Okay. Region is simply a geolocation or geographical location. What is this geographical location? If you see in AWS, we are having some 36 regions across the world. Like in India, we are having Hyderabad and Mumbai locations, and in America, you are having 4 regions. In another countries, in London, you are having 4 regions. What are these regions? Regions are nothing but a geographical location. For example, let us take Mumbai region. So when we select the Mumbai region, when AWS is selecting that it is a region, it's just a geographical location where AWS can have their data centers. So what will be there inside the data centers? So if you see data center, look at here. This is how the data centers will be looking like. I just want to take this image is. Okay, data center is there. So this is the data center. Somebody has taken the picture secretly, I think. See there, these are the racks. Okay, so if you see, they are bended, but actually these are how the racks will be looking like. I said, inside the data center, inside every company, there will be a data center. Inside that, you will have the racks. In the same manner, here also you are having the racks here. And these racks, inside these racks, you will have the servers. Okay, so and then the network equipment will be there, like firewalls, routers, and patch panels, switches. These are all the network equipment. And in the another rack, you will have the servers. Okay, inside the servers, you can create the virtual machines. That is altogether different thing. But here in this racks, you will have the servers. Okay, so now like this, if you are having the data centers, if in AWS also, to provide the infrastructure for you, AWS will also have the data centers. So where they will have these data centers, they will have these data centers in a geographical location. Okay, any geographical location in which the AWS will have its resources, then that is called as a region. Okay, so this region is divided into multiple availability zones. Now what is meant by availability zone? See, you have a single office. You are having a single office in Hyderabad. Okay. Now you have the what I can say. You are having the employees across the Hyderabad city. Not only the employees. For example, you are running, or else let me take a simple example. You have a shop, mobile shop. Rather than taking the IT company, let me take that mobile shop is there. So you install this mobile shop only in a particular area, in the Gachbowli location, or else in the Amirpet location, you put that shop. So you are giving the very good quality, I mean very good mobiles, and as well as the price is also very comfortable price you are selling the mobiles. Okay, so for example, outsiders are selling like 6,000 mobile for 7,000, 7,500. You are selling at 6,500 at that range. So that what happens, everyone will come to that particular shop only. Now, if the load increases, if the number of customers are increases, then what you will do, you are going to plan an another branch in an another location, so that the load will be distributed across the multiple branches in the same manner. So whoever are coming to your shop, they will be split, they will be distributed across these two branches, and still the load is increased, you are going to create one more branch. So now here, if the first branch is down, okay, if the first branch is down in the sense due to some reason, uh, you shut down or else you closed the shop for one day. So now what happens, all the traffic will be, all the customers will be going to the rest of the shops, okay, the remaining shops which you have created. So your profit, your money will be continuously generating. Okay, how it is generating? Because we have the high availability of the high availability of that particular product. Okay, so in the same manner here also, availability zones, what is meant by an availability zone? So in a region, we are going to create the multiple availability zones. Why we need to have the multiple availability zones? Because for example, in Gachibowli location, because of heavy rains, I got the power disruption. Okay, so the data center lost the power. All the servers lost the power. Now, if I have only single availability zone, single data center, if the AWS is having single data center inside a region, then what will happen? Then when the power is down or else the entire data center is down, then automatically the application will not be available for the end customers. So this is not my requirement. I need to have the application availability 24/7 for all the customers. So for that reason, what I can do, I will create a data center in Gachibowli location, and I will create one more data center in the Uppal location, and I will create one more data center in somewhere near to 60 to 100 kilometers range of another data center will be created. So now these are called as availability zones. So what
Sir,
I am trying,
sorry for the interruption, sir.
yeah,
Can I drop? Tomorrow we have class. I need to go out.
no, tomorrow you want, oh, already it is 8:37. No? Sorry, my mistake. Let me complete this within 2 minutes. I will complete, and then tomorrow on
Tomorrow,
Monday
sir.
you will have the session.
On the same time, then, sir, 7:30.
No, on 8:30. So the demos are completed. Okay. So
Okay.
today is the last demo. The demo is completed.
Okay.
Those who
There is.
are interested, they can join it. The session. The session will start at 8:30 a.m. on Monday. That will be a premium session. Whoever are interested, they can pay the fee and they can join the sessions. Okay.
Oh, okay, sir. Thank you.
Okay, so I will fastly conclude this. First of all, let me complete this geographical location and I will go back to the. So we are disrupted from things. Why? Because I have to tell you about this. Otherwise, whenever I am creating the resources, you won't be able to understand why we are creating this. So for that reason, I am telling you all this. Otherwise, there is no necessity. For example, if you think this is the region, in this region, what we are going to do, we will be having the multiple availability zones. Why we need to have the multiple availability zones? So that in this availability zones, you will have the data centers. So now what will happen? For example, inside the data centers, again, you will be having the server racks, and inside the racks, you will have the physical servers. Inside the physical servers, you will have the virtual machines, all the things. But as of now, what you are having here, so these are the availability zones. So here you will have the data center. Okay, you can have a single data center, or else in an availability zone, you can have the multiple data centers also. Okay, so you can have the multiple data centers also. All these data centers are connected to each other. All the availability zones are connected to each other, and as well as all the servers are connected to each other. So now what happens? For example, I have an availability zone or a data center in the what I can say, in Uppal location. Okay, now I want, so this data center is fine. Inside the data center, we can have our servers and it is running fine. Suddenly, due to the power disruption, what happened? The entire data center went down. The entire availability zone went down. So the application will not be available for the end customers. So my requirement is that I want to make sure that the application will be available 24/7 by the for the end customers. So I can use another availability zone. Here also I can create one more server. So in this data center in availability zone 1, I can create a server. In the availability zone 2, I am going to create the same server. The replica of the server will be created over here. Then what will happen? Whenever the request is coming, I will be having a load balancer. Whenever the request is coming to this load balancer, it can send it to this server or else it can send it to this server. Okay. But if the server is down, if this server is down, then the request will be continuously sending to this server so that the application will be highly available. So that is the reason we are going with the availability zones and subnets. Okay. And that is about your global infrastructure. So what you will have in an AWS environment means you will be having a region and you will be having an availability zone. These are the physical infrastructure. Now we need to talk about the virtual infrastructure that we will do in the Monday session. Let me save this. And create documents. Let's save it. Okay. So that's it from my end. If you have any further questions, you can ask me. And the session timings will be, the session will start at 8:30 a.m. This is what we are thinking of. If there is any changes, we will let you know. And then you will get the videos and documents, whatever that are required for you to practice. You will get all the videos and the documents. And what else I am missing here? That's it. Okay. Every day you will have the session, guys. Every day. Okay. There won't be any holidays for you. Most probably you will have the session at every day. 1 or 2 weeks, I cannot say that, depending on my workload. Either 1 week or the other week you won't have the session, but most probably you will have the sessions on every day. Now your questions.
Sir, regarding that timing, so have you checked with
That is what I said. Okay. So we are checking out. I just need to check out. So until you get a proper, like by tomorrow you will get a mail confirmation that or else mail or telephonic conversation. So depending on that, you can check out. Okay. I know your problem, but see,
Okay.
I have a session at 7 o'clock. Okay. There we are going with the Kubernetes. Then definitely I have to close that batch. Then I cannot take it at 7:30.
Okay. So like I just want to ask one more question.
Mhm.
In near future or like in 1 or 2 months, you will start a new batch that will have classes at 7:30 a.m. Is it possible?
Not only 2 months, but within maybe within 15 to 20 days, I will have another session at 7 a.m. I think. I don't know. Maybe I cannot confirm you that, but
Okay. A
you will get
possibility are there.
a possibility can be there.
Okay.
Right? Okay then. Anything else? Okay. Have a nice day. And the demos are completed, guys. From Monday onwards, we will have the session. So have a nice day and we'll meet in the next session. Bye.
Thank you, sir.
Thank you.